Welcome to you all in my YouTube channel Experience Mathematics. Today I am going to prove trigonometrical identities involving trigonometrical ratios of multiple angles. This is my second video on the proving identities involving trigonometrical ratios of multiple angles. Before starting, I want you to make sure that you subscribe my channel and encourage me to make more videos, and also press bell icon so that you will be informed about my coming videos. So now without delay, I'll start my today's topics. Here we have to prove this identity. Here is 4 cos q 20 degree plus sine q 10 degree equals to 3 inside bracket cos 20 degree plus sine 10 degree we have to prove. So from power we have to change the trigonometrical ratios without power. So we can use the formula which gives the trigonometrical ratio without power. Okay, from power to without power. Okay, we have to use that type of formula. Okay, before starting, we have to make our strategy. Okay, constantly we should look towards RHS. Okay, which method give us RHS? We should search that method, or we should use that type of formula. So in proving identities, from the same result we may reach to the different results. So here our result to be obtained is RHS. So we should try to get RHS, and we should use formula also accordingly, right? And the benefit in this proving identities is that RHS is the answer of left hand side, and left hand side is the answer of right hand side. So from LHS, if you start and if you get RHS, then you will be 100% sure that your answer is correct, you have done it correctly. And from RHS, if you start, then if you get LHS, then you will also be sure that your problem solution is correct. Okay, so that's the beneficial thing. The other thing is that from the same result we may get different result, and from starting from one side, if you do not get another side, then we will be in trouble. Okay, so with suitable practice we can get from one side to another side. Okay, so some important problems of these compound angles or multiple angles I am continuing. Okay, so I hope that this some important problems will generate enthusiasm in you, and it will produce chain reactions in you, so that after solving these questions you will be encouraged to do more questions on multiple angles. In examination also you will be able to prove trigonometrical identities. And if many students can prove trigonometrical identities in examination with the help of my video, and I simply suppose that my efforts are rewarded. Okay, let's begin this question. Let's start from left hand side. Left hand side we have this equals to, let's multiply this, 4 cos cube 20 degree plus 4 sine cube 10 degree is on the left hand side. I multiply by this 4 to each terms, and we have a formula of cos 3 theta, that is 4 cos cube theta minus 3 cos theta. We have this formula, and from this formula we can make another formula, that is 4 cos q theta equals to, if it goes other side, cos 3 theta plus 3 cos theta we will get. So 4 cos cube theta equals to, we can write cos 3 theta plus 3 cos theta. Okay, so for this 4 cos q 20 degree we have made formula here. And similarly we have next formula, that is the formula of sine 3 theta, that is 3 sine theta minus 4 sine cube theta. So from this also we can make another formula, that is 4 sine cube theta equals to 4 sine cube theta equals to 3 sine theta minus sine 3 theta. Okay, we can make this another formula for 4 sine cube theta, and we will use these two formula. 4 cos cube theta equals to cos 3 theta plus 3 cos theta, and 4 sine cube theta equals to 3 sine theta minus sine 3 theta. Okay, so here there is no power, okay, in cos and sine, so that we will be able to get this RHS. All right, now let us use this above formula. In place of theta we have here 20 degrees, so it will be cos 3 times 20 degree plus 3 cos 20 degree. Okay, so for this 4 cos q 20 degree we have written this much using this formula. And for 4 sine q theta we use this formula, that is in place of theta we have 10 degree, so this 4 sine q 10 will be 3 sine 10 degree minus sine 3 times 10, it will be 30 degree. Okay, and now cos 3 times 20, it is cos 60 degree. Cos 60 degree value we know, that is 1 over 2 plus 3 cos 20 degree plus 3 sine 10 degree minus sine 30 degree value we know. Okay, so we can use a calculator also to find out value if we do not know. Okay, so in class 10 you are allowed to use calculator, so if you have difficulties to remember formula, you are allowed to use formula and find out value of sine 30, that is 1 over 2. Simple. Minus 1 over 2 and plus 1 over 2 can be cancelled. And now from these two 3 is common. 3 is common, and we get cos 20 degree plus 3 is already common, so here is sine 10 degree left, which is our right hand side. So in this way we have proved this identity easily in 1, 2, 3, 4 steps. Okay, it is long question, but if you just know this formula, then it is not difficult to prove this. So if you need to copy this question, you can pause the video and copy it. And now I will move to next question. So next question is question number 6, and here we have to prove that cos 60 degree plus theta and cos 60 degree minus theta times cos theta equals to 1 over 4 cos 3 theta. Cos 60 degree plus theta, cos 60 degree minus theta times cos theta equals to, we have to prove 1 over 4 cos 3 theta. All right. So in this also, let's begin from left hand side. So here we can use 2 cos A cos B formula, but here is no 2, so we can multiply numerator and denominator by 2. So 1 over 2 times 2 cos 60 degree plus theta times cos 60 degree minus theta times cos theta, we can write, and for this 2 cos 60 plus theta and cos 60 minus theta, we can use formula of 2 cos A cos B, and we know the formula of 2 cos A cos B is cos A plus B plus cos A minus B. Okay, we have this formula of 2 cos A cos B. So this formula can be used in this case. Here in place of angle A we have 60 plus theta. In place of angle B we have 60 minus theta. So we can use 2 cos A cos B formula. Then if we use that formula, it becomes 1 over 2 cos A plus B. In place of A 60 plus theta, plus from the formula, in place of B we have 60 degree minus theta. It becomes cos A plus B, and now plus cos A minus B we need. Okay, plus cos A minus B, 60 plus theta minus 60 degree minus theta cos A minus B it became, and outside there we have cos theta. Okay, for this we have used cos A plus B cos A minus B formula. This is just like A, this is just like B. Cos A plus B cos A minus B formula we have used. This cos theta is outside there, and this implies now minus theta plus theta can be cancelled. Similarly, here this minus 60 and plus 60 can also be cancelled, and now we have 1 over 2 cos 60 plus 60. 60 plus 60, it is 120 degree, and here plus this minus times minus it will be plus, plus theta, and theta that will be cos 2 theta, and outside there we have cos theta. Okay, and here cos 120 degree value, you can find out cos 180 minus 60, and there's cos 180 minus 60 equals to minus cos 60 without using calculator, or using calculator directly. Calculator also gives you value of cos 120 degree, that is minus 1 over 2. That is the value of cos 120 degree, and here we have cos 2 theta, and here we have cos theta, and if you multiply this 1 over 2 times minus 1 over 2, 1 1 is 1, and plus times minus, there is nothing means plus, plus times minus minus, 2 2 is 4, and this cos theta also multiplies inside, cos theta, and plus this 1 over 2 multiplies here, 1 over 2 cos 2 theta times cos theta. Okay, so generally what is mistake student will do is that they will multiply this and this, but they forget to multiply by this cos. So this cos will multiply this will multiply this, as well as this will multiply this, and this will multiply this. Okay, so from these two are outside, so the term contain which is outside, that will multiply each term inside bracket. Okay, you have to be careful in that regard. So now minus 1 over 4 cos theta, and here we can multiply numerator and denominator by 2, So it becomes 1 over 2 times 2, and here will be 2 cos 2 theta times cos theta. Okay, we have multiplied by 2 in numerator and denominator. Again we can use 2 cos a cos b formula in numerator, and here we have minus 1 over 4 cos theta plus 1 over 4 using 2 cos a cos b formula. Again cos a plus b, that is cos in place of a 2 theta plus theta, that will be 3 theta cos a plus b, plus cos a minus b, 2 theta minus theta, it will be theta. Okay, I have written it directly. So here in place of a we have 2 theta, in place of b theta, so cos a plus b, 2 theta plus theta, 3 theta, cos a minus b, 2 theta minus theta, theta. Now here we have minus 1 over 4 cos theta plus 1 over 4 cos 3 theta plus this 1 over 4 cos theta, this plus 1 over 4 cos theta and minus 1 over 4 cos theta can be cancelled. So this equals to 1 over 4 cos 3 theta, which is RHS, equals to RHS proved. Okay, in this way this important question of proving identities involving trigonometrical ratios of multiple angles we have proved. Okay, and I suggest you to practice similar type of questions from your book. And so here also before I describe this question, you can copy the question, and you can once try yourself to prove, and if you can prove it yourself, then it's okay. Otherwise you can watch the video and then get technique and try it again. So now let's move to the next question, and if you need to copy this one, then you can pause the video and you can take time to copy it. So now I will start doing next question. Okay, now our next question is prove that six questions we did. Now question number 7. Question asked to prove that here cos 3a minus cos 2a plus cos a over sin 3a minus sin 2a plus sin a equals to cot twice of a. Okay, our question is prove that cos 3a minus cos 2a plus cos a over sin 3a minus sin 2a plus sin a equals to cot twice a. This we have to prove. And in such question, here we have cos 3a minus cos 2a plus cos a. So here cos d minus c formula or cos c plus cos d formula we can use. Okay, so but here if you take this and this, 3 plus 2 5 over 2, that will be in fraction. So fractions are difficult to deal with compared to the whole number. Okay, so I suggest you to take the two angles. You should take two terms so that sum of the two angles is divisible by 2 and difference of the two angle is also divisible by 2. So it will be convenient to take first and last term first, and this we can leave for later calculation. Okay, here also we can take this and this term at first. So let's begin from left hand side. So left hand side, here we first of all write cos 3a, and we can take last term plus cos a. In plus or minus, yes, we can take any two terms together, minus cos 2a over this sin 3 and sin a we can take together, sin 3a plus sin a minus sin 2a is here. Cos 3a and cos a we have written together, and minus cos 2a, sin 3a plus sin a, and minus sin 2a at last. And we can use now cos c plus cos d formula. Okay, we have the formula of cos c plus cos d equals to 2 cos c plus d over 2 and cos c minus d over 2. So cos plus cos, it will be cos cos. Okay, here if plus, then there will both will be cos. And here in place of c we have 3a, in place of d we have a. So where there is c we replace by 3a, where there is d we replace by a in this formula. So it becomes 2 cos 3a plus a over 2. Okay, this cos 3a plus cos a equals to cos 3a minus a over 2 minus, here we have cos 2a over the sin c plus sin d formula we can use. Here in place of c 3a, in place of d we have a. So our formula of sin c plus sin d is 2 sin c plus d over 2 and cos c minus d over 2. We can use that formula. So it will be 2 sin 3a plus a over 2 and cos 3a minus a over 2. Okay, sin c plus sin d formula, 2 sin c plus d over 2 cos c minus d over 2. So this, in place of c we have here 3a, in place of d we have a. Okay, we have used this formula, and here at last we have minus sin 2a. Okay, now 3a plus a 4a over 2, this is 2 cos 4a over 2, cos here 3a minus a, that is 2a over, here is 2, minus cos 2a, and from this 2 sin 4a over 2 and cos 2a over 2, from here minus sin 2a. Now we have 2 cos 2a and cos a minus cos 2a over this, here 2 sin 2a times here cos a minus sin 2a. Okay, so here we have simplified. 2 2s are 4, 2 2 can be cancelled, here 2 2 can be cancelled, and now After this we should take out cos 2a common from this. Some students cancel this 2 and 2 also. Here is minus sign, you can't cancel, okay, don't make that mistake. If here is multiplication sign, then only we can cancel 2 and 2 in numerator denominator. But if here is minus sign or plus sign in the middle, then this coefficient in numerator denominator can't be cancelled. Okay, it can be cancelled only when there is bracket here. Okay, then we can cancel, but here is no bracket. Okay, so you can't cancel 2 and 2 up and down. So we can simply take out cos 2a common. Cos 2a is common, and we have 2 cos a minus, after you take out cos 2a, 1 is left here, cos 2a, 1 is a cos 2a. And from this 2 also we can take out sin 2a common. Here is 2 cos a minus sin 2a, 1 is a sin 2a. Okay. After taking out cos 2a common, here remains 2 cos a. From here cos 2a can divide this one time, 1 remains here. Sin 2a is common from this, sin 2a here, 2 cos a. Then sin 2a divides this one time, so 1 is here. Now here sin 2a, cos 2a can't be cancelled. 2 cos a minus 1, 2 cos a minus 1 can be cancelled in numerator and denominator. Okay, this can be cancelled. So after you cancel that, cos 2a over sin 2a, we can use cos theta over sin theta formula. Okay, our formula for cos theta over sin theta is cot theta. Okay, you know the formula of cot theta over sin theta, sorry, cos theta over sin theta. Cos theta over sin theta formula is cot theta. Okay, we have the formula of cos theta over sin theta, that is cot theta. Cos theta over sin theta equals to cot theta. We can use that formula, and using that formula, this cot 2a over sin twice, cos 2a over sin 2a will be cot twice a. Okay, so in place of theta we have 2a here. Okay, so cos twice a over sin twice a equals to, it will be cot twice a. Okay, so now we can write this equals to cot twice a, which is our right hand side proved. Okay, in this way we have proved this question of the multiple angle. Okay, now look at next, another important question of proving identities involving trigonometrical ratios of a multiple angle. This is also the important question, and this is also the question in which students are frequently confused. Okay, so let's begin this one. Here yes, cos square a plus sin square a cos 2b, and then cos square b plus sin square b cos 2a. So while looking these questions, it seems like that it is not possible to prove from LHS to RHS, because angle A has been changed to angle B. Okay, so let's begin this question. Let's start from left hand side. Our left hand side is cos square a plus sin square a times cos 2b, and here cos square a we can write as 1 minus sin square a, plus we have here sin square a cos 2b, and 1 minus from these two sin square a can be taken out as common. Here will be 1 minus cos 2b. Okay, 1 minus cos 2b. Sin square a has been taken out common, minus times plus will be minus here, and this cos 2b here. And now 1 minus sine square A, and this 1 minus cos 2b formula is 2 sine square b. Okay, this is 2 sine square b. Okay, formula for this 1 minus cos 2b is 2 sine square b. Okay, how that formula comes, look at here. Our formula of cos 2 theta in terms of sine is 1 minus 2 sine square theta, and when this comes to left side, 2 sine square theta equals to 1 minus cos, this has no sign, means plus sign, goes there and becomes minus cos 2 theta. 2 sine square theta equals to 1 minus cos 2 theta. So this 1 minus cos 2b, this is 1 minus cos 2 in place of theta b, we have theta here. 1 minus cos 2b will be 2 sine square b here, okay, using this formula. And now in multiplication, we can write any two terms together, all right? So we have here sine square A and 2 sine square B. This 2 and sine square A we can write together. 1 minus, we can write 2 sine square A inside bracket, and outside there is sine square B, all right? And again, for this 2 sine square A, we can use this formula, okay? 2 sine square theta equals to 1 minus cos 2 theta. So in place of theta we have A here, so 2 sine square A equals to 1 minus cos 2A. Okay, 1 minus 2 sine square A formula is 1 minus cos 2A. Outside there we have sine square B. And now 1 minus the sine square B multiplies each term. This multiplies 1, this multiplies cos 2A. So sine square B 1 is sine square B, minus times minus plus sine square B times cos 2A. Okay, sine square B 1 is sine square B, minus times minus plus sine square B times cos 2A. Okay, now we need here cos square B. So how to get cos square B? This 1 minus sine square B formula is cos square B, because you know that 1 cos theta formula is 1 minus sine square theta. So 1 minus sine square B is cos square B. Cos square B, and this is same like this, so we can copy without changing this, because we have got what is needed in RHS. So while proving